Now is it visible? Jasola, please.
Yes.
Correct. During elimination, reaction. During elimination reaction, hydrogen from that carbon is removed. Which bears lesser number of hydrogens. And forms more substituted alkene. In short, in elimination, a more substituted product is preferred. That is why when we have a product like when we have a reactant like this, in the presence of alcoholic KOH, it's going to give me this as a major product. This as a minor product.
Excuse me, sir.
Yeah, tell me.
Sir, right now you are dealing with the chemical reactions, right?
Yes, chemical reactions.
So before that, the preparation's over, like in this batch.
Yeah, like preparations are over and SN is also over. Okay. So for that,
Okay.
there will be things like you have to like, but don't worry about the preparation right now, because preparation is not related to chemical properties, right?
Yeah.
Anna. So you can watch preparation on your own, and then we can have some extra classes in which we can discuss the doubts if you have any in preparation.
So can you send that video also?
Okay, I have sent you the whole playlist, right?
Yeah, in that it is there, right? Okay. So
In that everything. In that
okay.
everything is okay.
Okay.
Okay. I hope everyone is done. Now there is a question related to alcoholic KOH and aqueous KOH. So see, for example, if I have the same thing with the BR here, don't write now, please listen. And if I use aqueous KOH and not alcoholic KOH, I'm using aqueous KOH. That means I prepared my solution in water, then I get a substitution reaction and OH gets replaced here. There comes a question. There comes a question. Reactions of haloalkane with aqueous KOH, it gives substitution and it gives alcohol. But reaction with alcoholic KOH, it gives us alkene. These are what? These are alkene. Why? This is one of the very famous question, very favorite question of CBSE. That is why please write this. Reaction of haloalkane with aqueous KOH gives alcohol. but gives alcohol. Wait a second. Gives alcohol via substitution. Via substitution. But reaction with alcoholic KOH gives alkene. And it gives alkene via what? It gives alkene via elimination. Why? So see, this is a two-part question, and you will give reasons for two things. Okay, you will give reasons for two things. First, you will give reason why aqueous KOH it gives substitution, and then you will tell why alcoholic KOH it gives elimination reaction. Okay, it gives elimination reaction. That's the question is asking here. So write the first point. Please write this with me. Once you write this, then we'll explain the whole thing. Right? Since alcoholic KOH contains alkoxide ion. Since alcoholic KOH contains alkoxide ion, which is stronger base due to its large size. Due to its large size and high charge density. High charge density. Due to its large size and high charge density, it can eliminate hydrogen from beta carbon. It can eliminate hydrogen from beta carbon and forms alkene. So we have explained why it is. So in this statement, the question will understand, okay, fine, you understand why it is giving me alkene. Now you have to tell the questioner that why aqueous KOH it gives substitution. So write that. But in aqueous KOH, hydroxyl ion are present, which is a weaker base and good nucleophile due to its smaller size. Hence, it cannot eliminate hydrogen from beta carbon and gives alcohol via substitution.
Sir, can you scroll a bit up so I can take the photo?
Why you are not writing?
I'm writing, sir, but I couldn't complete it.
No.
Okay.
Let me know if you can't. Okay. Write this down. Done, guys? Yes or no? Please tell me. Yes. Abia, Fahad, Kinza, Muhammad Umar. Assalamu alaikum, Muhammad Umar. How are you?
Walaikum assalam, sir. I'm fine.
How's your dad?
Huh?
How's your father?
It's fine now.
He's fine now. Okay.
Yeah.
Okay. Okay. Fine. Done, guys. Everyone, yes or no?
Now I'm still writing.
Writing. Okay, right. Done, yes or no? Is there anyone who is still writing? Okay, everyone is done, right?
Yes.
Okay. Now, let us explain why it is happening. So we have our simple haloalkane like this. Please understand this very well. We have here hydrogen, 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 and hydrogen, and here we have Br. Okay. And we have two different cases. We have alcoholic KOH. Now, what is alcoholic KOH? Alcoholic KOH. So here we'll have some alcohol. Alcohol means ROH. Right? So ROH, it mixes with alcoholic KOH, okay, and there is dissociation happens because what is aqueous KOH? Sorry, what is alcoholic KOH? It is a base, right? So there is a reaction which happens something like this. Anna? So you can see that this OH negative will attack here, and you will get RO negative plus K positive plus H2O. So the negatively charged species that we are getting here is what? RO negative. That is why alkoxide ion. Okay, so from alcoholic KOH, what do I get? I get RO negative. Now, what is RO negative? Generally, it is ethanol. We use as alcohol ethanol. So if I take the example of specific example of ethanol, it will be CH3, CH2, O negative, which is present in the solution in a large quantity because it is we are using as a solvent. Now, this particular molecule, it is very big. And also this CH2 molecules and CH3 molecules are giving more and more electron towards the oxygen atom and increasing its electron density. So it is big and very unstable. It is very reactive because it is big and it is also having very high charge density. Now, let us look at aqueous KOH. So in aqueous KOH, we will only have OH negative. We'll only have OH negative. If you have water, so water can also dissociate into what? H plus and OH negative. So the only negatively charged species that you are having is OH negative. Now, OH negative is small and it is also, relatively speaking, it is having less charge density because oxygen, it does not have anything which is giving it electron. There is no electron donating groups in the hydroxyl ion, right? Now, what is going to happen here? If I talk about the reactant molecule, the substrate that we have here, haloalkane. Now, this substrate here, there is a delta positive on this carbon atom because of higher electronegativity of Br, and Br is pulling some electron density. Now, if this gets delta positive, this carbon will pull electron density from here. This carbon will pull electron density from all of these hydrogens, right? All of these hydrogens. So evidently these hydrogens also get delta positive. These hydrogens, they are also delta positive due to inductive effect. Br is electronegative. It is pulling electrons from carbon. This carbon is pulling electron from this carbon, and this carbon is pulling electron from all of these hydrogens, right? Now, this hydrogens are also delta positive. Now, this OH negative is so small that it can easily go and it can do a reaction here. But this big molecule, which an OH negative is not also having so much charge density. That is why it can wait for a while. It can make some adjustment and it can move here and attack on this carbon atom. But this RO negative, the alkoxide ion, it is very highly dense in charge. It is very reactive. That is why it cannot wait and it will just dump the electron on the first thing that it sees. It has delta positive charge, which is this hydrogen atom. It will dump the electrons here. As soon as it dumps the electron here, this will go here, and this Br will leave. And you will be getting, if I take the green route, I will be getting carbon. This hydrogen is abstracted by the alkoxide ion. We'll be getting CH2, double bond carbon. This Br has left as a leaving group. We have the two hydrogens, CH2. So we have got an alkene here. But if I take the red path, then I will be getting here what? I will be getting here. This CH3 is as it is. Nothing has changed there. No reaction is taking place. But the second carbon, the Br is leaving and the OH is attacking. So we will be getting CH2OH. Now this is what? This is a product of substitution. So we'll write substitution product. And here you will write elimination product. So write this down if you want to write this down. Otherwise, in your examination, this is enough if you write these two lines. So the Br will also read with the red path. So what is the main reason? Due to large size and high electron density and high charge density on the O negative ion, it becomes very reactive and it dumps the electron wherever it finds the nearest and the most easiest place to dump its electron. That is the H positive ion of beta carbon. Done everyone? Yes or no? Please tell me.
No, sir.
Okay, right. And please make the green one first. Okay, Abhiya is done. Please make the green one first. Understand it. It is attacking on this hydrogen atom. This hydrogen is dumping electrons and forming a pi bond here. And then since carbon cannot form 5 bonds, it will break the bond which is easiest to break. So CH bond is very tough to break, but CBr bond, because it is polarized, it is easier to break, and Br is a good leaving group. It will leave and you will form alkene. Here, the oxygen is attacking on the delta positive carbon atom, and this carbon atom, since it cannot form the 5 bonds, it will be breaking one of the bonds, which is the Br bond, evidently, because it is a good leaving group and the other bonds are more strong bond. That is why this Br bond will break easily, and OH will get attached on that carbon atom. While you're writing this type of mechanism, please try to say things what are happening so that you understand also. Done? Yeah, guys. Done or no? Abdul Rahman, can you please turn the mic on and tell me what did you not understand? I have given you the reasons now, and the reasons are also written in the answer. Read it and tell me what do you understand, but whatever is written. Miss Abdul Rahman, can you please turn the mic on? What happened, Abdul Rahman? If you can't turn the mic on, please like rejoin the class. Sometimes it happens that you will not be able to turn the mic on. Okay, so rejoin the class maybe. No. Can you please speak? हमने तो जो कहा है, I will be repeating the same things here there. Okay. So I want to understand what problem you are having. So can you please speak whatever you have understood till now from the statements that we have written and from the mechanism that I explained right now. What did you understand till now? Tell me.
So algo oxide is a stronger base, and due to its larger size, it can eliminate hydrogen.
No, due to its larger size, it can eliminate hydrogen and it cannot attack on this carbon. आप देख पा रहे हैं ना? Because this carbon is inside this whole shell of hydrogens, right? The hydrogens are outside and inside we have carbon atom. Now, since it is big, it cannot travel inside this carbon atom, and it is also very reactive. So it will not even wait to travel. It will get a positive charge and it will attack there. Got it? Yes or no? Please tell me.
Yes, sir.
And that's what I said. Actually. Okay. Right, next, reaction with metals. Okay. Now, those who were not present in the last class or the last class or the last class, they will also understand this class. Reaction with metals. Reaction with metals. Number one, reaction with magnesium. Please write with me. Please write with me and listen to my voice and don't look at the screen right. Okay, when you are writing, so you will be fast. Please write. When alkyl halides react with magnesium in the presence of dry ether, they form okay, Muhammad Umar, they form a compound with formula RMgX called Grignard reagent. They form a compound with formula RMgX called Grignard reagent. Yes, Muhammad Umar, what are you saying? Can you hold the class for 2 minutes for some problem? Okay. Okay, all of you are done, yes or no? Please tell me.
Yes, sir.
Okay, fine. Now see, what is RMgX? See here, we have R, Mg, and X. Okay. Now what is this R here? R is the organic part here. And as you can see, what is Mg? Mg is a metal. So these type of molecules in which we have a bond between carbon and metal, these type of molecules are known as organometallic. metallic compounds. Now, there is something very interesting about these organometallic compounds. There's something very interesting about this organometallic compounds. Now, if you look at organic chemistry is mainly composed of carbon, followed by hydrogens. We'll see a plenty of hydrogens. Okay. Now, both of these have similar electronegativity. Then the most important ones are oxygen, nitrogen, and the halogens. All of these three, they will be very common in your organic chemistry: oxygen, nitrogen, and halogen. And you can see the chapter's name also: haloalkane, haloarene. Alcohol, phenols, ethers, they all have oxygen. Aldehyde, ketone, carboxylic acid, they all have oxygen. And then amines, nitrogen. So all of these three molecules, these are what they make a plenty of organic molecules. Now, if I make bond with carbon of oxygen or carbon of nitrogen or carbon of halogen, I will get a delta positive charge on carbon atom. I'll get a delta positive charge on carbon atom. But if you look at this particular Grignard reagent and other organometallic compounds, here Mg is metal, which has a tendency to give electrons. And that is why this R, the carbon atom, will be getting a delta negative charge here. And this magnesium will be getting a delta positive charge here. So it is one of the very rare instances where the carbon atom gets a negative charge and it will be able to attack on any electrophilic site, So this Grignard reagent will be very useful in the preparation of many molecules and many compounds. Okay, so please remember this, that the carbon atom here, it contains what? It contains a delta negative charge. It contains a delta negative, partial negative charge. Okay, so these are organometallic compounds. Now, what is the reaction we saw? The reaction will be Rx plus Mg in the presence of dry ether. When I say dry ether, please don't think that it is not liquid. Dry ether is a solid, it is liquid. But why it is dry? Dry means it is it does not have any water. And we will also see why it should not have any water. So in the presence of dry ether, what happens? There is an insertion reaction which happens, and Mg gets inserted between this R and X. Okay, so we have got RMgX. So this is known as, the naming will be like this. R is alkyl. Whatever alkyl group you have here, if you have CH3, it will be methyl, alkyl, magnesium, halide. So we can write a few reactions here. Please write with me. If you have CH3, CH2X plus Mg in the presence of dry ether, I will be getting CH3, CH2. Okay, wait a second. Instead of X, please write Br. We are going a bit specific here. So this will be what? Ethyl, magnesium, bromide. Similarly, if you have something like this, chlorine, Mg in the presence of dry ether, Mg and Cl. This will be what? This is a phenyl group, so this will be phenyl, magnesium chloride. Write these three reactions. Also, please remember this reaction, and also remember that the carbon atom of Grignard reagent, all of these are Grignard reagent. Okay, all of these are Grignard reagent. Carbon atom of Grignard reagent, it contains a partial negative charge. It is electron rich. The type of reaction in which we reverse here we have delta positive for R, and here we have delta negative for X, but here we get delta negative for R. So this type of reaction, these are known as Umplong reaction. If you ever study chemistry, then you will read many reactions of this type, which are Umplong. Umplong means reversal of polarity from delta positive to delta negative. Done, everyone? Yes or no? Please tell me. Yeah, guys, done or still writing? Done. Check. Now let us see why this Grignard reagent is prepared always in anhydrous conditions. Please write with me. Question. Grignard reagent is always prepared in anhydrous conditions. Explain. So the answer is, please write this with me. Since Grignard reagent is very reactive, since Grignard reagent is very reactive in nature, since Grignard reagent is very reactive in nature, it's very reactive in nature, it reacts even with moisture. It reacts even with moisture and gives alkane How? So for example, once we have prepared the Grignard reagent, we will have CH3, or let us say R, Mg, Br. Okay, R, Mg, Br. And let us suppose there is some water present. So what is water? Water is HOH, right? H2O. Now this H will be having delta positive. This R will be having delta negative. Sorry, it will be having delta negative. And what is going to happen? This R negative can easily attack on this hydrogen atom. Okay, and it can form RH plus this will be getting Mg BrOH. Okay, so if you want a specific reaction, then you can take CH3MgBr, methyl magnesium bromide. It can react with water and it will form CH3 and H. It will give you CH4 methane plus Mg BrOH. Done? हाँ guys, done? अरे यस नो कुछ तो बोल दीजिए, आप लोग इतना टाइम लगा देते हैं.
Yes, sir.
हाँ, यस बोलिए फिर. Very good. So I hope all of you understood what is the reason why the Grignard reagent, and this is also one of the very important questions. Okay, so 1 marks में ये आराम से पूछा जा सकता है. Just if it is asked in 1 marks, you'll just write the statement here. That will be fine. Okay. So this reasoning type of questions, it is one of the most favorite. Only reactions, सिर्फ reactions नहीं आते हैं. Okay, so alcoholic KOH, aqueous KOH, that reasoning also it is very important. Right, the next reaction, that is reaction with sodium. A reaction with sodium. There are 3 reactions that we will learn with sodium. Number 1 is, all of these 3 are named reactions. Number 1, Wurtz reaction. Number 2, Fittig reaction. Number 3, Wurtz-Fittig reaction. Okay, Wurtz-Fittig reaction. Now, if you understand the Wurtz reaction, you will understand the Fittig and Wurtz-Fittig also. So please focus on the Wurtz reaction. Right, number 1, that will be our topic. Wurtz reaction. Wurtz reaction. Write with me. When two same haloalkanes react with react with sodium in the presence of react with sodium in the presence of dry ether. They form alkenes containing double the number of carbon atom. Alkenes containing double the number of carbon atom. Double the number of carbon atom. Okay. And then you write, and the reaction is called Wood's reaction. So basically, this reaction is of haloalkane with sodium in the presence of dry ether, giving you R, double the number of carbon atoms. Okay, so 2 moles of this will be required, 2 moles of this will be required. But even if they don't give you 2R, still you will be making the same reaction. You can write the byproduct also, 2NaX. Done, guys? Yes or no? Please tell me. Done? Yes or no?
Yes.
Yes. Okay. Now see, I will teach you how to make the products. Okay. Please remember how to make the products. If you have been given what is happening here, if I will show you guys what is happening here, we have RX. There are 2 molecules of Na, right? Na. Now this bond is breaking. This one Na is making 1 NX. This is breaking 1 NX, and R and R is getting bonded. R and R is getting bonded. Okay. So please remember this pattern. This is how the molecules are made. For example, let us take an example of CH3Br. Okay, CH3Br plus 2Na in the presence of dry ether. It will give you what? CH3. It will bond with CH3. CH3, it will bond with CH3. Let us say if you have CH3, CH2, Br plus Na. यहाँ पे आप बाई प्रोडक्ट बना लीजिएगा अपना. Okay. Now see what is going to happen. Whenever you get this type of thing, you just make the carbon atoms containing, please listen very carefully, make the carbon atoms containing the halogen opposite to each other. Okay. They should be facing each other. CH3, CH2, CH3, CH2. Okay. And now just make a bond like this. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
Yes, Fahad, Kinza, Mithun, Apia. Any
Yes,
problem?
sir.
No problem, right?
No, sir.
No problem. Okay. Now listen. If you have something like this, CH3, CH, CH3, and we have a, let us say, iodine here, plus Na. Then what will you make? How will you make? We'll draw it like this: CH3, CH, CH3, CH3, CH, CH3, and the bond will be between these 2 carbon atoms because these are the 2 carbon atoms that is containing halogen. दिख रहा है कि नहीं दिख रहा सबको? Yes or no? Please tell me. Can everybody
Yes,
see
sir,
it?
yes, sir.
Yes.
Yes, yes.
Okay.
Yes.
ठीक है. Now try this one. Tell me the product. Mithun, you don't have my number now. Let me send you my number. And when you are done writing this product of this reaction, then what you are going to do, you are going to send me a photo on WhatsApp. Okay, Mithun?
Okay, sir.
Same goes for everyone other. सबके लिए को काम करना है. I'm waiting for your answers, okay? जैसे ऊपर वाला जो था ना, it is like this. This will give you some idea. अच्छा, dry ether is present, okay? I've not written, but dry ether is present. The same molecule. This is the same question. बस इसको ऐसे बनाते हैं, ऐसे बनाते हैं, इन दोनों को कनेक्ट कर देते हैं. That's it. Do the same thing here also for this reaction. Okay, I'm getting some answers. Very good, Kinza. Very good. Correct, right. Muhammad Umar, I have received yours. Correct. Why you are using a different notebook today, Muhammad Umar? Abhiya, correct, very good. Muhammad Umar, what happened? Why are you using a diary today and not the notebook?
No answers for that.
Ek notebook. That means you don't have one notebook.
No, I have one notebook for chemistry specifically.
But what happened then today?
Oh, no, I don't have any answers for that question.
So change the notebook now at least. If you don't have any answers.
Sure, okay.
Okay. Fahad, correct. Abdurrahman, correct. Adriel, checking yours. Correct, Adriel, very good. Correct, very good. So see, they will not give you the questions like this, okay? For this, they will ask you how will you convert 2-bromo, 1, 2, 3, 4 butane. Okay, I think Mithun, I have received yours. Yes, Mithun, correct, very good, correct. 2-bromobutane, and they will ask you the product. If you see it is what it is, 3,4 dimethyl hexane, है ना? So we have here 1, 2, 3, 4, 5, 6. So 3,4 dimethyl. This is my longest chain. because since we don't have any functional group around saturation, so the longest chain will be the one which is containing the most number of carbon atom. That will be our parent chain. So now this is we have 3,4 dimethylhexane, and this is one of the conversions. Okay, one of the conversions in your chapter. Since you're done, let us look at the mechanism, what is happening here. Then we will write a few more points. Let us write the mechanism and understand what is happening. Okay, listen. First of all, the two sodium atoms, they will dissociate into Na positive and they will give you 2 electrons. And we have a haloalkane, Rx. Let me make the 2 electrons. These 2 electrons are going to react with our good old haloalkane. This is delta positive. So this electron will attack here. Okay, this bond will break. Now please remember what is happening here. See very carefully. This bond which I am making with green bond here, it consisted of 2 electrons. It was a covalent bond. One of the electron was bought by R, and the other electron was bought by X. But when this happens, when this bond cleaves, when this bond breaks, what happens? X takes both the electron. X takes both the electron. Now, when it is taking both the electron, it will form X negative. But this R, it has given 1 electron, but it is getting attacked by 2 electrons. That is why it will also get R negative. It lost 1, but it gained 2. So net gain was of 1 electron. That is why R negative. And also, if you look at the charge, in the reactant side, the charge is -2. And in the product side also, the charge is -2. So it is perfectly balanced reaction. Don't worry, here we have both the negative charges, X negative and R negative. Now, further on this R negative, it reacts with another Rx molecule. Here also it is delta positive and this is delta negative. This R negative, it attacks on this R. And what do we get? We get R. So it is a what? It is a nucleophilic attack, right? It is because happening on the carbon atom. Okay, Adriel, you got disconnected. Second step is important. In the second step, 2 electron is attacking the R alkyl group or the carbon atom, because carbon atom is having positive charge because it is connected with a more electronegative element, that is halogen atom. Halogen atom is pulling electrons, carbon is getting delta positive charge, and hence it is attacked by electrons. Now, when the bond breaks between carbon and halogen, halogen take its own electron as well as 1 electron from carbon because it was a covalent bond. Now, carbon is losing 1 electron but gaining 2 electrons. That is why it will get R negative. Then this R negative will attack on some other molecule of haloalkane. It will attack on other molecule of haloalkane, and then it will form RR. Then it will form what? It will form RR, not RRR, but it will form RR. And RR is what? It is alkene containing the double the number of carbon atoms. Now, write a remark. Write a remark. The remark is, this reaction is not applicable. The carbon with negative charge has to attack on carbon. Okay. This reaction is not applicable for 2 different haloalkanes. As they give mixture of alkanes which is difficult to separate. No, Fahad, but mechanisms are important to understand some questions. Okay, some questions. Have you written the mechanism, all of you? So no, please tell me. No or yes?
Yes, sir.
Right. जो चीज लिखने के लिए कहा है लिखिए. I will tell you what not to write. If it is present, please write. एग्जाम में सब आता है, ठीक है बिहारी, आप हमसे कोई नहीं पूछेगा एग्जाम में ये आता है क्या, ये वो नहीं आता है क्या, एग्जाम में सब आता है. नहीं आता तो पढ़ाते ही क्यों? I hope now you're done. 3 lines of mechanism. If you are not done, please let me know. Okay. Now listen, don't write. Listen now, don't write. When the reaction is not applicable for two different halocane, why? Because let us see, if I have CS3Br and I react this with CS3CH2Br plus sodium in the presence of dry ether. Now, when I write this reaction, I hope you understand that I don't have only one molecule of CS3Br and one molecule of CS3CH2Br. We have millions of molecules of CS3Br and CS3CH2Br. Okay. So what will happen? Some of the CS3Br, they will react with themselves and they will form CS3CH3. Some of the CS3CH2CHBr, they will react with themselves and they will form CS3CH2, CH2, CH3. And there will be some in which the cross reaction can happen. Both of these can react with each other and they will form CS3, CH2, CH3. Now, all of these are what? All of these are alkenes. They are correct reactions. These are correct products, but these are what very difficult to separate because they have one carbon less than each other. So difference in carbon is only one. That is why the separation is difficult. They will have similar physical properties, and we can separate things only on the basis of physical properties. And if the physical properties will be similar, we cannot separate them. The most common physical property is boiling point. And when we have similar boiling points for the carbon atoms and for the hydrocarbons, then we will not be able to separate them. That is why it is not done. It is not applicable for two different haloalkanes. And we don't do this type of reaction. Please write this reaction now. And the 3 products. And the products that you are going to get. Some CS3Br will react with itself. Some CS3Br will react with CS3CH2Br. Similar thing will happen with ethyl bromide. Some ethyl bromide will react with themselves, and some ethyl bromide will react with methyl bromide. So when methyl bromide reacts with methyl bromide, it forms ethane. When methyl bromide reacts with ethyl bromide, it forms propane. When ethyl bromide reacts, it forms butane. And separation of these are difficult. That is why we don't do this type of reaction. Is everyone done? Yes or no? Please tell me. Is
Yes,
everyone
sir.
done? Okay. Write the next point. Wood's reaction. Now, this is important, and you will understand why the mechanism is important now. Wood's reaction is not shown by Wood's reaction is not shown by tertiary haloalkane. As they undergo elimination, and form alkenes. Let us see a 3-degree, a tertiary haloalkane. CH3 carbon we have any halogen atom here. When it will react with 2Na will give electron. The electron will come and attack on this carbon atom. And what we will be getting? We will be getting CH3 carbon, CH3 negative, right? This is the R negative as we have seen in the reaction. Now, let us look at the another haloalkane that we have here. Now, Can you see that this is bulky? This is very big, yes or no? Please tell me. The C negative that we have formed, it is very big, yes or no? हाँ या ना जल्दी बताइए. Yes or no, guys? It is very big. This R negative is very big, yes or no?
Yes, sir.
What happened? बाकी लोग को आवाज नहीं जा रही, बाकी लोग को समझ में नहीं आ रहा, बाकी लोग को दिख नहीं रहा है क्या? That this is big. हाँ. Yes. मिथुन, किंजा, फहद, एड्रियल, अब्दुलरहमान. तो फिर बोल क्यों नहीं रहे? Is this big? Yes or no? Please tell me. The R negative that we have here, if you look at the mechanism, 2Na, right? It gives you 2 electron. This 2 electron reacts and it will give you R negative. This R negative, then it has to attack on this X atom. Now the R negative that we have here, is it big? Yes or no? जवाब ही नहीं आ रहा किसी का. Yes,
Yes.
Yes, sir, it's
Abdurrahman.
big. It's big.
So now if it's big, then tell me, will it attack on the carbon atom or it will attack on the hydrogen atom? Will it attack on the carbon atom or the hydrogen atom? Please tell me. Where will it attack? Carbon or hydrogen?
Hydrogen.
Hydrogen, yes or no? बाकी लोग जवाब क्यों नहीं दे रहे? हाँ? Where will it
Hydrogen.
attack? Hydrogen, right? Now, if it is going to attack on the hydrogen because it is big, it cannot travel towards carbon atom. It will also, the CH3 groups are electron donating, and that is why the charge density will be very high. It is very reactive, very big. That is why it will attack on the easiest hydrogen that it gets, and it will form what hydrogen is getting attached here. This hydrogen will leave the electrons. It will form a double bond here, and as soon as the double bond forms, the carbon is forming now 5 bonds. It will break the most weak bond. It will break the most weak bond. This is with X. It is a good leaving group. And what we are going to get? We are going to get the CH3 will get CH3, CH, CH3, CH3. Okay, so this has became an alkene now. Plus here what we'll get? Here we will get CH2. Let me write it here. Double bond carbon. One CH3 here and one CH3 here. So this CH3 I have just written here. So here we are getting alkene. And this is not Wood's reaction. Please write this down. Okay, so mechanism aata hai, right? Until unless you know the mechanism, how will you understand that this will be C negative here? And they will ask you, why Wood's reaction is not shown by tertiary haloalkane? NCERT mein nahi diya hua, but they will ask you this question. Why Wood's reaction is not shown by tertiary haloalkane? Give reasons. Done, everyone? Yes or no? Please tell me. लिखा कि नहीं लिखा? नहीं लिखा, जल्दी लिखिए. Done, guys? Yes or no? Please tell me.
Yes, sir.
So this is all about the Wood's reaction. Now the rest of two reactions, that is Fittig reaction and the Woods-Fittig reaction, that is quite easy to understand now, right? Fittig reaction. Okay, so how are we numbering this? Are we numbering this or we are putting hash? Numbering with blue. Fittig reaction. What is Fittig reaction? You take one halorene, react this with sodium in the presence of dry ether. and we will get just double the same thing is happening here. Same thing is happening here. Please remember, if you get something like this, let us see. Br, let's see, you have CS3 here. Dry ether. Then what you will draw? You'll draw it like this, CS3. Okay. And then you will face this carbon atom, this carbon atom in the same direction. Then you will, if you flip this one, what you will be getting? Please remember, I have flipped this. Okay, I flipped this just to make this carbon atom facing the same carbon atom here. And we have CS3 on which number carbon atom? After 1. So this carbon atom was containing Br, this is vacant, and this is containing CS3. Correct? Correct. You'll get a product like this. Okay, write this down. When haloarene reacts with sodium in the presence of dry ether, they form biphenyl. है ना? This is also known as diphenyl. ठीक है, दोनों नाम है, कंफ्यूज मत होइएगा. I hope you have written the first reaction at least. Okay. So there is a conversion in your NCERT. They are asking how will you convert benzene to diphenyl or biphenyl. दो बार पता नहीं क्यों NCERT ने सेम सवाल दिया हुआ है. एक बार लिखा हुआ है how will you convert benzene to biphenyl, and then they have written how will you convert benzene to diphenyl. Diphenyl एक बार, biphenyl दूसरी बार. So first of all, what we'll do halogenation, because halogen तो चाहिए है ना. Whenever you see the doubling happening, जब भी डबल होता रहेगा ना कोई चीज, so what you will be doing? You will be first of all making a halogen. Halogen बनाने के लिए we will use Br2 in the presence of FeBr3, and we will be getting Br, but अब जस्ट इसका रिएक्शन किसके साथ? Na in dry ether. Na in dry ether. It's one of, I mean, दो सवाल है conversion से. Same thing is happening, but there are two questions. Write this down, then we'll look at the Wurtz-Fittig reaction. If Fittig हो गया, then we'll write the Wurtz-Fittig. Done, everyone? Yes or no? Please tell me. Yes, guys, done?
Yes, sir.
Done. Okay. Achha, Abhiya is writing. Okay, Abhiya. Done guys, yes or no, please tell me. आगे बढ़े ना? Okay. Right, Woods fatigue reaction. Third one, in reaction with sodium, Woods fatigue reaction. Okay. So in Woods fatigue reaction, we take one haloalkane. We take one haloalkane. To say we have Br here, and we take one haloarene. One haloalkane, one haloarene in the presence of sodium and dry ether. What do we get? We get alkyl benzene. We get alkyl benzene. Okay, so please remember, if you have something like this, in the presence of dry ether, you will be getting CS3. So this CS3 which is here with Br will get attached here. But if you have something like this, the presence of dry ether. So please remember this carbon atom, which contains two other methyl groups that will be attached. You have benzene ring, and here you will get. So this is the carbon atom which is attaching, which is containing two methyl group. When haloarene and haloalkane are treated with sodium in the presence of dry ether, they form alkyl benzene. Let me know when you're done. Done guys, yes or no, please tell me. No, still writing. Then let me know if you're done, or let me know if you're not done. Write the topic, chemical properties of haloarenes. Chemical properties of haloarenes. Now, even though the last two reactions, they are also reactions of haloarene, because here we are having a haloarene which is reacting, and the phytic reaction is purely haloarene, the reaction of haloarene. Okay, but still we keep this in the reaction with sodium, so it is easier for you guys to remember. And we will look at the chemical properties of haloarene. The first thing that you will see here is a question that they can ask. So please write with me. Haloalkanes show SN, but haloarenes, please write this with me, okay? Show electrophilic substitution. Why? Okay, so here we have two questions and we have to answer both of them. Okay, please don't answer only one of them. कि haloalkane Hn so क्यों show करता है और haloarene Hn haloarene electrophilic substitution क्यों show करता है? You have to answer both the things. Give the reasons for both of them. Why haloalkanes is showing Sn, and then you will give the reason why haloarene is showing electrophilic substitution reaction. That is Se. Okay, electrophilic substitution reaction is Se. Please write the answer. In haloalkane, the alkyl group is attached to halogen atom, due to which partial positive charge is created at carbon atom, and hence electron rich nucleophile attacks the carbon atom of CX and shows SN. This is the reason why haloalkenes, they show SN. We have RX, and RX here, this is delta positive and this is delta negative. Nucleophile can come easily with its electron richness and it will attack on this R group. This X will leave. This is the reason why haloalkenes show SN. Now we will give the reason why haloarenes, they show electrophilic substitution. So write with me. But in haloarene, you write in here. But in haloarene, the benzene ring right has high electron density, That means we have an electron rich substrate. If the substrate haloarene is electron rich, what it will do? It will attract the electrophile. Hence, electron poor electrophile. Hence, electron poor electrophile is attacked by haloarenes showing SE, electrophilic substitution. Okay, so please remember यहाँ पे you will not give the reason why haloarene is not showing SN. They have not asked this question. They have asked. Okay, Fahad, write this down. Fahad, write this down. What they have asked why the haloarenes are showing electrophilic substitution. They don't want to hear why it is not showing SN. That is another question that can come. That is another question which will come. Why haloarenes do not show SN? So the answer for that will be different. Now they are asking why haloarenes show electrophilic substitution. So you have to give the reasons why it is showing. Please exam में confuse मत होइएगा. Both of these questions can be asked. Write this down. Let me know when you are done. And then we will move on to the different electrophilic substitution reactions of haloarene. Done, guys? Yes or no? Please tell me. Yes, is everyone done?
No, sir.
Kinza, लिखिए जल्दी लिखिए.
Done, sir.
What about others? Is there anyone who is still writing? Is there anyone who is still writing?
Yes, I'm writing.
Okay, Fahad, right. Done, guys? Yes or no? Please tell me.
Yes, sir.
Yes. Fahad, what about you?
Yes, sir. Done.
Done. Right. Electrophilic substitution of haloarenes. Electrophilic substitution of haloarenes. Now you write here. Haloarenes show the following SE. So these are the electrophilic substitution reactions that you must have heard in 11th standard. Halogenation. Then you will see nitration. Third, we will see sulfonation. Fourth, we will be seeing Friedel-Crafts. Alkylation. Fifth reaction we'll be seeing is Friedel-Crafts. Acylation. चलिए यहाँ तक लिखिए. Then we will start with halogenation in the next class. Acha, also next class you will be having a viva. It is ending now. This will happen in class, and the topics will be elimination reaction and reaction with metals. No. No, Muhammad Umar. And this week, I think on Sunday on the app, you will have a MCQ test also. So for MCQ on Sunday, I think it will happen on Sunday, most probably. Okay, it will happen on app on Sunday. So for that, I will give you the syllabus on Wednesday. That means on the next class, I will give you the syllabus for the MCQ test. Please write this down also. The topic elimination and reaction with metal, it will happen in class. In class or after the class? Okay, done guys, yes or no, please tell me.
Yes, sir.
Okay, so thank you very much. Let me know if you have any doubt from this class. We can discuss it now. If not, then you can leave. We'll meet on Wednesday. Thank you very much. Bye bye. Take care, guys. Please revise. Please revise now. ठीक है? अभी class खत्म हो रही है. Revise whatever we have done. Write the reactions once again. अभी लिख लीजिए. Whatever reactions we have done today, write those reactions once again. Now only. Okay? चलो. Thank you, guys. Thank you very much. Bye bye. Take care.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir. Bye.
Thank you. Bye bye.
Sir, about the assignments in the app, right? When will they get posted every time?
When you will
Yeah.
get a message on WhatsApp, right? Whenever they are posted.
No, I got them. I didn't get any messages like for like the past
On
week or so.
past week or so.
I didn't get any messages for assignments.
Just a second.
The last message was on 8th.
8th July.
Yes.
नहीं. Nope. I have given assignment. Fahad, Muhammad Umar, did you get any assignment?
No, sir.
No.
No.
I have shared the assignment. And what about Fahad? Acha, Fahad left.
Have you shared it in the group?
No, not in the group. It will be on the app.
Let me see.
On the app. Okay, they have not updated. Let me see.
Yes, sir, it's not updated.
Sorry,
It's not updated.
it's not updated. So what is the last assignment that you are seeing?
Effects of SN1. Something.
Factors affecting SN1 and SN2.
Yes.
Okay. Did you get this assignment, Adriel?
Sir, I'm talking about the group, not the website. In website, I have the assignments.
ग्रुप में कुछ नहीं पोस्ट होता है. ग्रुप में क्या पोस्ट होता है?
No, I was asking about like, do you know like at what days will it be posted? Like, is there like a specific day?
नहीं, जैसे आज क्लास है ना, तो कल तक वो पोस्ट हो ही जाता है जनरली. If it is not posted, then I have decided to not give an assignment.
So like after every class there will be assignment, right?
हाँ.
Okay.
I mean, after every class, there will be assignment. And in some classes, I feel like there is no need of assignment. And if you are having some kind of test or something, then I don't give the assignment. Okay.
Okay.
But generally, after every class, we'll see an assignment.
Okay.
Sure. ठीक है. Okay.
Thank you.
Thank you. Bye-bye.
Sir, can you solve my doubt?
हाँ, sure. Tell me.
So it's actually in the mechanism of Ward's reaction.
हाँ, tell me.
Why have we written +2 electron?
Why?
Why have we written +2 electron?
Because sodium is a metal. Na? Sodium has a tendency to lose electron. And we are using 2 sodium atoms. So one sodium atom will give 1 electron. The other sodium atom will give another electron. And hence 2 electron. Got it?
Yes.
That means I'm not saying that only 2 sodium atoms will be reacting, but there will be multiple sodium atoms, right, which will be giving electrons. Now, 2 of those electrons will attack on alkyl halide. Got it?
I have to break the bond and then.
Okay, makes sense?
Where
Okay.
is this another R group coming from?
Where is this?
Another R group coming from to attack to the R group again.
No, this R negative.
The R negative.
We have just created that R negative here, na? See? One thing, एक चीज आप हमेशा दिमाग में रखिए. How many molecules do we have of haloalkane?
One.
How many molecules? Tell me.
One.
Millions.
है
ना? We have millions of haloalkane in the solution. ना? तो reaction का stoichiometry अलग है. Okay, the reaction stoichiometry of reaction is different, but you should remember that there are millions of haloalkane. So one haloalkane is getting reacted. अगर एक का 2 इलेक्ट्रॉन्स पे अटैक कर दे रहा है, इसका मतलब ये नहीं है कि ना सारे के सारे haloalkane पे एक ही टाइम पे सारे 2 इलेक्ट्रॉन अटैक कर रहे हैं. There will be some unreacted ones. There will be someone which is reacting with 2 electrons of Rx. Okay, it is forming R negative, and the unreacted Rx will be getting attacked by the R negative. Okay, Mohammed Umar. है ना? So ये दिमाग में हमेशा रखिए that there are millions of atoms. Okay. Anything else?
I'm searching.
Okay.
So I didn't understood why Haloarenes show Lect reaction.
Why they?
Why do Haloarenes show electrophilic reaction?
Electrophilic में what haloarenes are what electron? ये statement में क्या समझ में नहीं आ रहा आपको ये बताइए आप. In this statement, what are you not understanding?
The last line.
Okay. Electrophile will be electron poor, yes or no? ये आपको समझ में आ रहा है? Right? And we have